Okay. Last time we finished off, well, a couple of different things, but today we're still working. We're going to finish this guy. We painted him last time with just some polyurethane, actually, like you would put on a floor or a tabletop or something. And we coated him with that, and he was really, really shiny. Even after he dried, he was very shiny. Like it was a gloss finish. And that was okay, except that it looked kind of weird because he was very shiny. So I did spray him with this, a lacquer, flat lacquer. So it's dulled him down. So basically, all I did that you didn't see was I did paint in like little eyes and teeth, sprayed him with this. I think I repainted the edge of the base because it had gotten some of the polyurethane on it. And that was it. So total painting time for this guy was probably in the 10-15 minute range, something like that. Now there is one thing left to do. Doesn't have anything to do with printing, but generally when you're painting these guys, you're almost required to put something on their base. Just, I don't know, that's just what you do. So I'm going to put one of these little guys on there, and we're going to call him Done. We'll put a little drop of glue. This is Aleene's tacky glue. It's pretty good because it's thick for holding stuff in place. It is thick though. Let's see. Let's put it over here. There's a little spot on his foot that looks a little crazy over there. All right. And we'll grab one of these and stick it right there. And now we're going to say that other than that thing, well, the little gravel stuff in here is not printed. But other than that, in the gravel, he's all 3D printed. Came out really good, I think, for something came off of our printer. You can, let's see if I can zoom in and show you some of the layer lines that you can pick up now. You can probably see some right there. Maybe. I don't know. It's hard to... Oh, yeah. If I can get him right in the right focus length, you can, yeah, you can see him there. So you can kind of see, but they're not bad. There's a couple across his back, but they're not bad. And this was just on the FDM printer. Later on, next week maybe, we're going to do some resin printing. So printing directly in a resin material with a printer that's not a lot more expensive than the Ender 3. So they're still on the much affordable end if you want to do that. There are some advantages to resin printing. There's plenty of disadvantages, mainly on the upkeep with dealing with it, but there are some advantages, particularly if you wanted a whole army of these guys. Like if you wanted a whole army of these guys printed on our Ender 3, it took about 3 hours to print one of these. So 2 of them would take about 6 hours, and 3 of them would take about 9 hours, and so on. If I wanted to print these on the resin printer, first of all, I would have thinner layer lines. You know, you wouldn't be as noticeable. They'd be much thinner. He'd be solid resin. So this guy is a little bit hollow just because I didn't make him completely solid. You can make him completely solid at this level because they're, you know, they're mostly, by the time you put a couple of walls in here, he's not very thick. So he would have a lot of solid material. But if I would make him solid resin on the printer, and if I wanted to put one of them, it would take I don't know, I haven't actually done that one with this. I have a new resin printer that we're going to try out, but it would take, I don't know, but let's say it's 3 hours again, just as a number. So multiple of him on the FDM style printer, you just multiply the amount of time. On the resin style printer, if it takes 3 hours to print one of them, it takes 3 hours to print as many as you can fit on the bed. Because the way they work, they expose an entire layer at one time versus tracing every little place that you have to put filament every layer. So if I could put 6 of them on the little print bed, now it is a smaller print bed than what the Ender 3 has, but if I could put 6 of them on there, it would just take 3 hours to print 6 of them. Anyway, I think he came out pretty good. I would not be ashamed of him. He looks okay. We did a really quick paint job. You saw me do some of it, and then I followed up with another maybe. It took me longer to pick the colors out than it did to painting. So We're gonna call him done. I don't know where the little mummy guy we did earlier is. I didn't paint him the same way, but they'll go away. On our not our sandblaster. Actually, sandblasting is something we're gonna do. You can actually sandblast the surface of some parts, and there are some pieces. I haven't printed them yet, but on our blaster, there's some pieces that hold the scope on, some little rings that I'm not sure the actual. These models were all kind of kit bashed together when they were making them back in the 70s for this would be from the 70s episode of Star Wars: A New Hope, Han Solo's blaster. So they were just made from parts all over the place. Some handmade things, a lot of parts that they looked like, hey, that fits. And so anyway, there's this rings that hold this on, and they look like they're kind of cast metal rings. They don't look like the other textures, and so I can't really tell. But I think I'm going to try, when I print those, I want to sandblast them. I have a miniature sandblaster. You don't have to have a whole cabinet for it. Now, I won't be able to do that live because that would just be too big of a mess. So I'll have to record that, and maybe we can watch it as part of the stream. But I have some walnut shells that I'm going to try blasting the surface to try and make that little indented kind of cast surface finish on that thing. So we'll try that. I haven't actually ever done that with a plastic part before, but walnut shells are generally used for plastics and things like that you don't really want to damage the underlying surface. So we'll try that and see. What I am going to do with this guy, though, is I'm going to sand a good bit of it. And I'm going to sand it. I've already sanded one piece. Well, I've began sanding one piece of the grips. I decided not to print them in the wood PLA just because we're running, we got 10-ish episodes left or so. Classes left. I don't know what you call them when you're watching them on TV or on whatever you're watching. So I didn't want to take the time to do the wood printing and all the other stuff we've got to get done. So here's one of these grips. These are supposed to be wooden. That's why I was talking about the wood PLA. So this is the original, what it looks like. These are printed at 0.2 layer height, and they are not bad actually, but kind of when it gets to the top, they were printed laying down like this. So when it gets to the very top layers, there are some pretty noticeable layer lines. On the sides, it's not really that bad at all. So I started sanding on this one. When I sand these things, PLA is not particularly simple to sand, or it's easy to sand. It doesn't respond well to sanding. And I use mainly stuff like this. So these little emery board type things, you can either get them as emery boards, or you can get them as sanding sticks, or you can make your own. Just, you could even print or create some piece of flat, whatever shape you need, and then spray glue or glue stick or whatever, some sandpaper to them, and you can make your own any shape you want. Like I might need to make some to fit down in these little grooves here if I want to sand down inside the grooves on here. We're really zoomed in, aren't we? Let's zoom out a little bit. There we go. This one's a sanding sponge, so it's a little bit flexible, but it does have some rigidity to it, and it's just coated in a sandpaper material, and they make these in different grits. This is the only one I actually have right now, so this is the one I'm using. The thing I like about these, and sanding something that I want to be sort of have a smooth surface, so particularly when I get over to here, and I want these to be, these are all kind of like a blackened metal, and this needs to look like blackened steel. So I want those to be pretty flat. I would rather sand as much as I can with something that's a little bit rigid. Even this is a little bit flexible here. Not very, but a little bit flexible. I'd rather sand with something rigid so that if you just took a sheet of sandpaper and sanded, you would have the tendency to sand little waves into the surface. Whereas if you have something that's relatively rigid, you have a little bit better chance of getting a flat surface across there, which is what I'm going to want for, particularly for this. I started with this piece just because it was the easiest one to grab at the time, and so you can kind of see that you can still pick up the layer lines probably across the top here, and I haven't really sanded this section because it's kind of curved in right there, so I'll have to I may have to just get a piece of sanding, or maybe sandpaper, or maybe make one of these that's round and put some sandpaper around it to get in that dip there. But you don't need to do a whole lot of sanding before you do any of your primer. So the next thing I'll do with this, I'll finish this sanding up, and I'll sand this one. I may sand on some of the others, but these will be the ones that we look at next. I'll spray them with the adhesion promoter, same thing I used on this guy. And I'll get that can out next time. It's put up right now. But I'll spray them with the adhesion promoter. It adds a little bit of thickness itself, so that'll fill in a little bit of these layer lines. And then I'll spray these, probably not with the same primer that I used on here. On here I used basically one of these, Model Master, but a white primer from them. I'll probably use a Duplicolor gray. It's a little bit thicker. You don't want to, or I don't want to put a super thick coat on here of primer. I'll spray that on there, and I'll probably sand it and maybe even spray it again depending on how it comes out. Maybe I'll do two so you can kind of see the in-between steps. Like take this one further, then I take this one so you can see the in-between steps. Anyway, that's our goal there. We want these to look like a wood. So I'll probably use that polyurethane again, since it is a wood stain, polyurethane, clear coat, all in one type thing. And these probably would be okay if they were a little bit shiny. We'll see how it comes out though and what it looks like. But that's my goal for those. If you do, some people, and even me, I like to sometimes wet sand things. Now I don't necessarily do that with the PLA directly, but with the primer on top of it. I do often wet sand, because what will happen is your sanding stick or sponge or paper, whatever it is you're using for sanding, will get clogged up. You can kind of see it happening here. You can get clogged up with the particles that you're removing, and you can wipe them off. That gets a little bit annoying to have to do that too often. Now the PLA doesn't come off as fast, but once I put some primer on there, it'll come off pretty fast. And I probably wouldn't use something this coarse. This is actually pretty coarse grit. This one's coarser than this side. But wet sanding, so using a bit of water or while you're sanding, will help not clog up the pores on your sanding, whatever you're sanding with. But your print is not 100% waterproof, and it can absorb some of that water. And if you don't get that water out of the print before you paint it, then there's a good chance that water is going to mess up your finish somehow. Now, these aren't going to rust or anything. Like if you were sanding on a car, then you might not want to trap water beneath the surface. So that's not going to be a problem, but it could still come back out. So you do want to make sure that the piece is completely dry. One of the biggest things that will happen is, like these little grooves right here, they'll have a little tiny bit of water in there. And particularly if you're spray painting. So if I spray paint over this, the next layer, with a little bit of water in there, that water is going to jump out everywhere and spray, and it's going to splatter in the surface, and you're going to have all these little pock marks in the surface. So you do have to be careful if you do wet sand, just to dry off everything before you get to the next phase of putting new paint or primer on top of what you just sanded. So that's, I think, all of our updates on where our existing projects. So let's start some new projects. Today we're talking a little bit about casting. Oh, well, other things. Sometimes you can't hold these parts very well. So I just took, this is the stick that I normally, stick these guys on to spray them. I just took some poster tack and just stick it on there, because you want to be able to get down to these edges, and some parts are just hard to hold. Stick them on something with poster tack. It'll work fine for holding them in while you're sanding, because, I guess I didn't specifically say this, while you're sanding, you're not actually like pressing down really hard to sand. You want the sandpaper itself to do most of the actual removal. If you press too hard, then you're going to, for one, it's going to create too much friction, and you can heat this stuff up to where it begins to melt a little bit. I would definitely not recommend using any kind of Dremel or any kind of rotary tool or anything to speed up sanding on this plastic. It will probably end up melting the plastic and gumming up all of your sandpaper or whatever. It's most of those are just going to run too fast. I guess if you took a variable speed rotary tool and had it really low, you could probably get away with that. But you can actually even begin to melt if you sand too fast with something like this. So probably if you begin smelling the same smell when this is printing, it has that, I don't know, it's a unique smell for PLA. You're probably getting to the point of almost too much friction on your sanding. So you don't want to press too hard for that reason. You also don't want to press too hard because you don't want to force your sanding block or stick to take the shape of whatever like curve here. You kind of want to sand across it and not too hard. Now we got sanding stuff everywhere. All right, casting. So why would you want to include casting with your printing? There's a couple of reasons. Some of them are it's because it is what you have available for making the thing you want to make copies of. So that's a good reason. You might have limited ability to carve something or create a part another way, and so you can 3D print it. And you could either print the part itself and then create molds around that to make copies of it. You could just print a lot of different things, but again, like on these guys, if I have an Ender printer or a FDM printer like our Ender 3, every time I make a new one, it's another 3 hours of printing. So that could add up to be prohibitive for me if I'm trying to make a lot of these things. So I want to make one or two and make a bunch of copies by casting them. So you could print them and create a mold like this one. This is not a mold I made. This is one I bought from, I don't know if you can see it there, but it says Hearst Arts. Probably can't see that. I'll put it in the link. It's not important, but since I showed it to you, I'll put it in there. So you could print, this one has, I don't know, 20 different things it prints. Well, it doesn't print. It makes if you fill them all in with plaster or resin or something like that. And so you could have printed all of these things and cast this silicone mold around it, and then this mold will make all of these parts, 50 times, maybe 100 times if you're really careful, but probably in the 50 time range before it starts to degrade. These molds do degrade over time. So you could do that. You could print the parts, cast a mold around them, and then use that mold to make copies over and over again up to some number of time. You might think you could print the mold itself, like print this part, and you sort of can. So the general thing is that if you are using a flexible mold, like this one's all flexible, then the parts that you're casting inside them can be rigid, because you can pull them out and there are even, you can kind of see down in there, there's undercuts. So this would make half of a barrel, and you make it twice to make a full barrel. So there's a little band there, and there's undercuts inside these. This thing's got a core in the middle of it. So there are undercuts under here, and to be able to get the part out, then one of these has to flex, either the thing you put in or the mold itself. So here the mold can flex. I have never actually tried printing a flexible mold. That is, you have flexible TPU type material, you could probably do it, and maybe we'll try that. Since I've never actually done that, we can try that. We'll try printing a mold in TPU and just see if it works, or how many times it'll work before it fails. We'll try that. Normally, the stuff that you're going to put in here, when it cures, it does heat up. It's an exothermic reaction, and it creates some amount of heat. I don't think it would be enough to damage the TPU instantly. Over time it might, or just the fact of pulling things out and pulling parts out of here would damage them over time, even for the silicone molds. So we'll try that. Not today. I'm not going to be able to have time in the next 20 or 30 minutes to print a TPU mold, but That's one thing we could do. We'll do that. In fact, let's write that down as something to try. And I'll see if I can get one to print something simple for next time. Now, next time we're actually spending most of our time. We'll look at the blaster again, where I'm at on that. But we're spending most of our time putting that SKR board in the printer. So we may not even have a printer that works after next time, but we'll see. I think we can get it to work. We'll figure it out somehow. So we could do that. We could print a mold directly in a material like TPU so it's flexible, and then we can cast plaster or resin. I have some resin over here somewhere. Yeah, right here. Some smooth cast 320 for basically creates a off-white mold or casting of whatever you've created. I think I do have a sample. Let me show you. All right, so it picks up a lot of detail. Let's see if we can get close to that. This is that same 320 material. And it's actually got one of the little barrel pieces from this mold in it, I think. One of these little pieces that broke, so I put it in here. And then some random rocks and little piece of stick and a bunch of gravel or whatever. So it picks up super fine detail. So the problem is going to be that we're probably not going to get a nice surface finish on our TPU mold, and we're going to have lots of layer lines in whatever we cast in there. And this stuff does pick up every little detail pretty much in there, even without some kind of vacuum or forced casting, just pouring it into the open mold, it will pick up a lot of that detail. We'll try it and see. So we'll try that. The other thing you could do is we could print a mold, a rigid mold, in regular filament like we use for our other prints, like the blaster over here, and then cast a flexible material into it. So you can cast, rubbers and foams and things like that into the rigid mold. So they're the part that flexes and you pull it out. So most of those, the problem with them is that they expand when they cast, and so you almost have to cover the mold. It has to have two parts or some cover over it, some way to keep the foam expanding down into the mold and not just out of the top of it if you want to pick up all those details. So that would be a little bit difficult, but there are ways you could do that. You could print your mold, make it in two halves, leave a pour hole in it, and pour the expanding foam, urethane, or whatever it is you're using in there and clamp the mold shut. I'm trying to keep it simpler than that with just these open molds that you pour stuff into and then you let it cure and you pull it out. So that's kind of what I'm not going to do that. I do have some foam in there that we could probably cast, but it's just you do have to figure out some way to contain it at least for a little while. So we're not going to do that one. Another thing you can do, let's say, so these are trying to get a resin in there, so something that's hard, plasticky material is as your copy. And this stuff does sand really well. So this, if I wanted to go into the blaster making business over here, we could make molds of one of these, cast them in resin or whatever. Now this is somebody else's design, so we'd have to go figure out, well, would they let me actually do that? I don't know, or I'd need to make my own. Anyway, cast a resin in there, and then they would sand really nicely, and we could have a bunch of them. I'm sure we could go on someplace like Etsy right now and find somebody that is selling this exact, maybe not this model, but this exact replica. And it's probably a decent industry to get into if you have a lot of time and you want to do a lot of sanding and casting. Anyway. What if we wanted a metal part? So there's a couple of things. There's kind of three ways. We're going with a metal part here, right? We're going to make this look metal. So that's one thing you could do. We still haven't gotten our rub and buff material in yet. So if we get to working on this before that comes in, then we'll just have to use some other techniques for making it look like metal. So you can make it look like metal, paint it up, give it some weathering so it looks kind of like the corners are chipped up and things like that. And you can make it look like metal. With these things, there are basically these really fine powders that you can put, you can coat the surface of the mold here. You can actually even mix them into the liquid resin before it's hardened. And they are sort of basically ground up metal particles that will make your part look pretty much like metal, because it will have some metal content in it. And it's just suspended in a resin, or if you coat the inside of the mold before you pour the resin in, then it kind of gets coated on stuck to the outer surface of your cast over here. So you could do that, and again, it just kind of looks like metal. It's kind of got some metal particles. Those, if you're using actual particles, this metal powder that is metal, then you can also weather them. You can make them rust. You can make them patina, like if they're copper or things like that. And there's fake versions of that too, just paints that make it look that way. But what if you want actual metal? So that's a little bit harder to do. There are processes where, I don't know if you've heard of a lost wax casting process, but basically the idea is you create your part in wax. There's lost foam, so styrofoam, and there is lost PLA, so PLA. So you create the part in one of those materials, and the thing about all those materials is that they're relatively low melting point compared to a metal's melting point, particularly foam and wax, and even PLA compared to like if you're melting aluminum at 600 degrees or whatever. So the idea is that you print part. You can actually print in wax on a FDM printer. I have not done that on a FDM printer. And I've never seen anybody actually succeed very well at doing that. Like there are some wax filament that you can attempt to use, but I haven't used them, and I haven't seen anybody actually use them very successfully. So anyway, you create your part, and then you surround it with a plaster-like material. It's called investment, but it's like plaster. And then the lost part of the PLA or the wax or the foam is that you put that encased, so you've got this thing encased in this plaster material, and you've got some sprues. They're called sprues and vents and gates and all that kind of stuff that basically are pathways. This would be a piece of wax, pathways outside of the investment. And you put it in a furnace, turn it upside down, heat up the furnace so that all of this lost material, the lost PLA or the lost wax or the lost foam, is melted out. Actually, the foam you can do, since it melts so simply, you can just pour metal directly onto it and it'll basically evaporate. But the others, the lost wax and the lost PLA, you have to melt out this part in here. And so you melt it all out, and you end up with the investment, so the plaster has this shape inside of it. And so you turn it back over, you pour your molten aluminum, usually you're doing aluminum or whatever material. Maybe if you're in the jewelry business, you're doing a precious metal of some kind. You pour molten material, metal material in there. It fills in that cavity, takes on the shape of the cavity, including all of the sprues and connecting points and everything, but mainly the part that you're trying to copy. And then you take the whole thing, you let it cure or cool for a couple of minutes to get hardened here. You drop it in a bucket of water, and that hot investment is basically plaster again. So you put the hot investment in water and it disintegrates, it breaks apart. So you can only do it one time before you have to go make a new mold. But then you get a really nice copy of whatever it is. A lot of times with this process there's a vacuum involved, so you're actually pulling the material into the investment to make sure it gets into all the nooks and crannies. The next time I go back to my office, I will grab a little tiny Millennium Falcon we made that way. So we did print it in on one of the resin printers and did this process to it. So that's a cumbersome thing, and you got to have special equipment and everything. What if you don't want to do any of that part, but you still want a metal part? There is another option that is similar to this kind of thing. So you print your part, whatever it is you're going to copy. that you want in metal. Maybe those coins we made early on when we did the 2-color 3D printing. Maybe you print one of those or a couple of those. And then you get something like this. This is casting sand. This is from Otto Frey, Delft clay casting clay. I don't know why they said clay casting clay, but they really want you to know it's clay. But this is a super fine clay sand, so that this you can pour metal into this without, you know, melting. If you poured molten metal into something like this or a 3D printed mold, it's just going to melt the mold. But in sand, there is a sand casting technique that you can use with something like this. We'll actually try this one. I think we can probably do it, not today, but I think we can probably do it live without too much problem, because mostly you melt the metal and then you throw it in. Now, we're not going to be able to do aluminum because you do have to have a much hotter temperature. Probably not something that you're going to have laying around, you know, a forge to go and melt the aluminum in. But you might have some pewter, and you might have one of these little guys. Now, you're not going to just have one of these laying around, obviously, but you can get these relatively simple. So this is basically, there's a heater on the bottom of this. There's no on off, there's nothing. There's a plug. You plug it in, it heats up. It has a little stand over here so you don't set it on the table. But it heats up. You wouldn't want this much. You cut you off a piece of this pewter, put it in here, let it go for, I don't know, 10 minutes or maybe. I'll have to actually time it to see how long it does take to melt. You melt it, and then this is your pour, your melt, your everything. Pour it into your sand mold. We're going to just do an open mold like this one, where you don't have to try and get a 2-part mold. That's a little bit more difficult than what we want to deal with. So you pour it in, let it cool, and then you've got metal copies of whatever it is that you were trying to copy. They are, you know, pewter, but the reason you're going to use something like pewter or a similar material, there's all sorts of low temperature casting metals, is the low temperature part where you don't have to have a forge to melt it. But I mean, it's going to look metal. It has the weight of metal. This little block, it didn't tell me how much it weighs. Let me see if I have a scale. Here we go. Let's see how much this little block weighs. So 18 ounces, so a little over a pound for a little block like this. So it has the feel of metal, and it's actually going to be, in our case, a little bit better because it's not going to tarnish in any real way. I mean, you get a little bit of tarnishing on there, but not anything significant. So that'll be a way that we at home, without having a forge or anything super expensive. I think these little hot pots they weren't expensive because I bought one, so I don't know. I have to look up the let me see if I can find it real quick. Yeah, $40. There's one for $25. I don't know where it's coming from, but in the $40 range, depending on where you get it from and if they have shipping or not. But this one is a little bit nicer than some of the super cheap ones because the super cheap ones are literally just a pot. You know, you could melt this stuff probably on your stove if you wanted to. I'm not going to do that. I'm going to use this thing because I have it. So in the $40 range. So if you're really interested in making copies of little metal pieces or metal copies of little pieces, then this would be a way to go about doing it. Now, you're not getting any kind of force into the mold, so you don't have really a head, if you know what that means. You don't have a column of liquid metal pushing the metal into the mold, so it's literally just sitting on top. It's one of these style open molds that we're going to do, so there's nothing forcing the metal down into all the little details. So you may not pick up a lot of details that you would want to get. So super fine thing like millimeter resolution details, you're probably not going to be able to get. We're not going to vacuum cast it, so we're not going to have a vacuum source pulling metal into our mold. It's going to be an open pore mold, and we're going to have to expect that it's not going to have super fine resolution. In fact, you can kind of see on here, see the top, they have a little symbol, I guess that's their logo, and you can see it there, but it is not super high detail. So this was in an open pore. You can kind of tell, but there's a sink mark where it kind of, when it cools down, it sinks. Most materials are going to shrink when they cool down. So you can kind of see that's going to be the top, and then there was just this mold sitting there that this was poured into. And we won't have this mass either. We'll have a pretty small, I'm thinking, why don't we make some of those coins? So what we'll need to do is we'll need to print us out some little coins. We'll need to create our mold, sand mold around them. So we'll need a little box, create a sand mold, and then pour a couple of them in there and see how they come out. So the back won't have any details on it. The back will just be kind of flat, and the front side will be the one. To do anything where both sides have details on them, that's a little bit more complicated. Probably not something you want to try on your first attempt at trying to cast something, just because you got to line up two different mold halves and get that working. I would recommend just doing something with an open mold to begin with to see how that works. The other thing you could do, not for now, we're off of metal now. We're just back into casting in general. So the other thing that 3D printing could do to help you out is, we're back to silicone molding. So to create this mold, what you have to do is you have to create all the little parts, and then you glue them down to a surface of some sort, whatever you want to copy. And you have to build a little wall around it and pour the silicone in to take up all the details and cure. You could envision a thing where you print all of that. So you print this, you print this, you print the wall, you print the little surface at the bottom, all as one piece. So you print your mold box and the things you want to mold and the bottom of the box all as one piece. So you just take that part with the walls and everything. You might clean it up, spray primer it, because you do want to try and not have those layer lines showing. It's going to be hard to sand inside there and all that. But I would, depending on the amount of detail you're trying to capture, primer it with some of your thicker primer. Maybe sand a little bit if you want to. But create that whole thing as a print, and then pour the silicone in, pull the silicone out, and you've got your silicone ready to go. So that doesn't necessarily save you time if you only do it once. So if you only do it one time, then it's probably not that much faster, or it's definitely not that faster, because it's going to take longer to print this with the walls around it than it would be to just print these two. And then manually go in and build the walls out of whatever material you want to build them out of. Some people use Legos to build them, the walls. So that wouldn't take long at all to do. But if you ever think that I'm going to cast this so many times that I will probably need to make another mold, or maybe I want to make 5 of these molds and do a lot of parallel processing on my casting setup here, that case it might be worth it to print the mold box and everything all as one time, all as one piece. Pour the mold silicone in, let it cure, pull it out, pour another batch in, let it cure, pull it, and you don't have to take anything apart. You just leave it there, and you can always go back and make another set. That might be worth it. So I think what we're going to do, that we're going to try that. I haven't ever actually done that. Every time I've done molding before, I just used, like for this one, I just found a cup that was a little bit bigger and cut the cup and glued this down inside there and poured the silicone inside the open cup and made the mold. I guess I could find the mold somewhere. I have to look for it though. Here's what we're going to do. Let's say, I was trying to think of something that why would you want to make a copy of a lot of things? Now, a copy of this guy, a resin copy of this guy, that's a much more difficult mold. We couldn't just glue him down, pour a bunch of silicone around him, and expect it to work. He's got this captured area right in under here that would probably be difficult for us to get him out of the silicone. Wouldn't be impossible. So I don't know if I even want to try it though. He's also got a captured area under between his legs and the base I put him on. So it would be tough to do something like this. Not 100% impossible, just tough. Because you'd have to put him in there, put silicone all around him, and then go cut the silicone apart, get him out, put the silicone back together, and pour your resin in there. Either that or do him in two pieces, like mount him kind of suspended in air, pour silicone around him, and then let that cure, and then pour silicone on the other half of him. You can do that. So that would be tougher. We're going to do something. Here's what we're going to do. We're going to do these little things. They don't look like they're going to be too hard. And look, they have the little grass tufts. I told you it was mandatory that you put that stuff on here. So you could just print these. Wouldn't be that big of a print. They look pretty simple to print. And even the layer lines that do show up on the print don't look like that big a deal. They kind of make the rocks look like rocks, sort of. So we could print those. Let's say we want to make a lot of these things, though. I don't really want to, but let's just say we do. So we want to make a bunch of them. So we want to make a mold and copy it over and over again. So here's our prints. Here's our little model. I think I've already downloaded it once. So what I think we should do is a combination of things between I'm going to use SolidWorks because that's the one that I have open right now. So we're going to use SolidWorks and this guy, and we're going to build, that's not SolidWorks, that's Cura. There's SolidWorks. First, I'm going to see if it'll let me open the STL part. Let's see, those probably got put in the download folder. There they are. All right, so they did come in. All right, so let's go in. They have a nice flat area for the bottom, so that's nice. Let's build our bottom off of that. So we'll build a extruded boss on. Oh, wait, it didn't come in quite on the the plane there, so I actually want to select it. See if we can. Oh, will it not let me select pieces of a STL the way I want to? No. Oh, yeah, you have to convert it, don't you? Actually, let's do. I'm trying to work through what I want to do here. Actually, let's just make a placeholder here, and then we'll go into Mesh Mixer and stick them together. So let's just make a placeholder here. So this is, you know, more, I don't know, we could actually save a lot. And make, this silicone stuff is kind of expensive, so you don't want to use more than you have to. So why don't we go in and make something that's pretty much like a copy of this thing. What I want here is an outline that I can offset by about 1/4 of an inch or so. That's a good amount of silicone to have as your walls. So like the distance between the different pieces here, about 1/4 of an inch of silicone is generally enough for it to not rip. So I like this idea. So we just basically traced it, and now let's offset these. And not by 10 millimeters though, let's by 1/4 of an inch. There we go. So this will be kind of the inner wall that we're going to create. And then well, actually that's the outer wall, isn't it? The inner wall will be more or less the shape of the part. Let's extrude it up let's see. I've got to invert this thing in my mind because I want it to print that. I want some walls. I want it to actually make the space be the space of the silicone that I want to keep. So let's see. All right, let's take and let's offset it again. I think. Offset. There we go. So this, we can get rid of this chain now. This was just the, we don't actually want that. We may be doing this backwards, but it'll be all right. Actually, we can get rid of our rock too. We don't, well, no, let's keep it in there because I need it to see what I'm doing. All right, now we've got our sketch done, I think, the way I want it. And we do need to extrude it up past, you want about 1/4 of an inch of silicone. So the idea is that we print something like this with the rock inside it, and then we can pour silicone in the opening part, take the silicone out, and we'll have our mold. When we pull the silicone out, now it's going to be one thing to pull it around the rock. We can't really do anything about the rock. It does have some undercuts. You can kind of see right there. It'll have to work its way around those undercuts to release off of them. But since the walls we have no real need for, we're going to put a draft angle on those walls. And a draft angle is just a angle so that they're not vertical. And that's used in vacuum forming and casting and all that, so that if you have walls that are not vertical, when you go to pull your parts apart, so the mold and the part you just cast, when you pull them apart, if there's that draft angle between them, it will make them much simpler to release. And we have to also remember that this thing is going to be 3D printed, so there's going to be all these little layer lines in there that are each one going to be trying to grab a hold of the silicone, because the silicone will take in all of those little details, including every little layer line. So we want to put a draft angle on here. I think that's going to be thick enough there. SolidWorks does have a tool for draft angles, right? Where's that? Draft, right there. So our direction of pull, now I always get this backwards, so I have to do it and then redo it. We're going to say we're pulling this way, which I think is right, because we're going to pull the silicone out that way. I've got a 5-degree draft. That's actually a large draft angle for most casting, but since we're doing this on a 3D printed part with all those little ridges that are going to want to grab a hold of the silicone, I'm going to go with 5. And then we want to draft this edge all in here. There's probably something like I can select a chain of edges, but there's not that many. I'll just click on them. And let's see if it, oh, there's another one. I wish it had a preview. It didn't show me a preview though. All right, so I've selected all the inner surfaces. I'm pulling it out. Let's apply it. Uh-oh, did it? Oh, I can't. Oh wait, all right, you can see it right there. See how that pink, oh, now blue line is not vertical anymore. If I look at this from the side, you'll be able to see better. Well, not from that side, you won't. Maybe from there. Well, you can kind of see. It is not vertical any longer. That's because we have applied that 5-degree draft. And so now when I go to pull this silicone out, the top part here that we're going to pull out is actually narrower than the base. So it should, slide out of there simpler. All right, so we've done our draft. We don't need another one. We do need a bottom on here though. So let's take, where's that sketch? Let's take that sketch and let's just, I don't want to make a different shape base. I might as well save all the material I can. So let's get this one. I'm just holding down shift and selecting all the lines here. I'm pretty sure there's a way to select them all at one time, but this is what I'm doing right now. So let's copy those. Oh, well, I'm not sure what can't be copied, but well, I guess we'll find out. So we're gonna make a new sketch on there, and maybe, actually we could just, you know what, we can just do this. Let's just take our new sketch and let's extrude that thing. Am I in the extrude? I want to, there we go. All right, something, I don't even know how I made a plane. Oh, that's probably, it's not from, yes, I want to delete that. They're at that. Let's just extrude this, but downward. We have to make the bottom on our part. Let's only make it a 1/4 inch. But I don't want the inner part. I only want the outer part. What's the easy way to do that? Well, all right, the super easy way to do that. Here we go. We're gonna sketch on here, and we'll find kind of the center. We'll make a circular base for it, and it'll be fine. Oh yeah, I didn't want to actually select that. Fine. Why did it do that? Well, what I want to do is create a new sketch. I don't know why it's giving me trouble. Yeah, don't know why it's giving me trouble. Now we've got a base on it. So I think I'd rather have the outline here, but this will be fine. We could go in there and fill it this also if we really wanted to. Our STL model is not actually connected to it though, right? It's just floating above there. So I think what we'll do, I could probably figure out how to get it to attach. There's a way that you can convert these things over to objects that SOLIDWORKS can actually use, but we're just gonna delete that. Here's our mold box. File, save as, and those walls actually look a little bit big to me. You know, I didn't actually measure how big the rock cluster is though. I guess we could have done that also. Save that. Let's leave that open just in case we have issues with it. Import that, and then let's import our, we're going to append it. I think it put it in here, didn't it? Oh yeah, that's just why I left SOLIDWORKS open, because I saved it, but I saved it as a SOLIDWORKS file. Where's the STL? There it is. Now, there's the box. All right, now we just got to put the rocks in the box, or the box over the rocks, whichever. Let's see. Edit, transform. And remember the little gizmo, we need to raise it up a little bit. Oh, that's tilting. Raise it up a little bit, and then move it into position over here. And get it where it's overlapping. Let's see. We're actually there is a way to make this guy kind of transparent. I don't remember which one of these is the transparent one though. Can't edit it. I can make it go. Oh, there we go. All right. So it's embedded a little bit too far, I think. Let's move him up. Still a little too far. All right, I think that is probably good. Like there's just a little bit of the rock parts embedded in the base of the rock box. So we should be able to now combine those. And now we have one piece that we can export as a STL, print it out, and we'll try pouring silicone in this guy next time. We don't have enough time to do any of that today. Plus, I'm not 100% sure that my silicone, this is what I'm going to use. Well, you can't even see it, doesn't have a label on it. I'm going to use this. Actually, here's the label. I'm going to use this, the 940 Platinum Cure silicone rubber. I'm not 100% sure it's still good. We will attempt, I'll make an attempt before we go live with it, just to see if the it's Platinum Cure, see if the silicone is still good. If not, I may have to get some new silicone. I usually get it from this Smooth On company. They have some giant, like 5-gallon things that are really expensive, but they also have these smaller quart size that are not so bad. And they generally last, you know, unless you're making these really large molds, they generally last for quite a while. And the way we're doing here, we're trying to only use the silicone that we need. So we've got the bare minimum size box. We might have a little bit thick here, but we don't have to fill it all the way when we go to pour the silicone in. So we'll have to test that out and see if we can get us a good mold for these little rocks. So I'll print that, and I'll get a setup for printing. Maybe I think I have to make some more of those little coins. I don't have any more, so that we can try a metal pour. I don't know how much of that we'll be able to do next time. Next time, the main thing for next time is we're going to be working with this. So this is where's it at? The SKR mini board, and with screen. So we did get the screen and the duct that comes with Big Tree Tech. Some heat sinks. There's the board itself. So it should be a drop-in replacement. It's just, are we going to be able to get our firmware working the way we want it and everything? We'll have to see. I don't know. I haven't ever actually used this board. So actually, there's the board. That's the screen. There's the board, and you can kind of tell that it looks very similar. Same layout and everything of what we've already used, or what was already in the printer. But the idea here is that the motor drivers are quieter, and we're gonna see how that works. We're gonna see how well the printer itself works, because it's actually working really well as is. We haven't really done any major changes. I showed you some of the, wow, things are just falling everywhere over here. I showed you some of the things that we had gotten to upgrade. One of them was the stiffer bed springs. I haven't put those on yet. Got the Capricorn tubing. I did find the tubing cutter. Now, these are basically just a really sharp blade and a groove for the tubing to sit in, so that you're pretty sure you're cutting it straight across the end here. Like you would just set this in, make sure it's in the groove, and there you go. You should have a pretty straight, clean cut across the end. You don't have to do this. They actually make ones that you can print and use a razor blade here. You can just be very careful and cut a straight line across with an X-Acto. The main thing is you want to use something that's very sharp, so that you're not crushing this tubing when you do the cutting. So you don't do any sawing or anything like that. You want something that's very sharp, so it just slices through there without crushing the tubing. If you make a dent in the tubing, then you're going to have extra drag on the filament as it goes through. So I think I will put this on now that I found this. It's just a matter of chopping it off to length like we just did, and then putting it in place of the existing Bowden tube. So that's, I'm not even going to show you how to do that, because it's pretty obvious how to do it. It's just the only key is getting the end of this thing very, very perpendicular to the axis of the tubing, so that when you install it in the hot end, you don't have a gap between the end of this tubing and what it rests against. In this case, it rests against the nozzle. So we do want to make sure that that is straight, and so these tubing cutters help. Sometimes when you can find on Amazon the tubing, this kind of tubing with this as a bundle, and it's, you know, a few dollars more than just the tubing. So I would get, if you don't have one of these, I would just get the bundle that had the tubing cutter and the tubing. The tubing itself, the advantage is that it has thicker walls, and it has supposedly, now I've not ever verified this, but it supposedly has a more accurate inner diameter to better match the filament that you're putting through it. We'll see if any of that is true. It does have thicker walls, I can verify that, and it is stiffer in general. But we'll see if it's any difference on the filament going into the hot end. All right, we will see you next time with our SKR mini board put into Ender 3, and hopefully we print some more parts. If that doesn't take too much of the time, then I want to do one of our castings, either the silicone or the metal casting, depending on where we're at on that. And I'll keep you up to date on where the blaster is at also. So see you on Wednesday.